Hello everyone, and welcome to this presentation on Advanced Design 2023. To introduce myself, my name is Etienne Lechasseur and I work at GRAITEC in Montreal as an application specialist. I provide training, demos, and technical support for structural analysis and design solutions. I also work with the dev team to help with the localization of our software for the North American market. In this session, I'm going to show you how to use the new features that were added to AD for the calculation of wood structure in North America specifically. As you may know, in the previous versions of AD, wood design was limited to Eurocode, but now it will be possible to use the Canadian OAD 619 and the American NDS 2018. This presentation will be focused on glued-laminated members, and I will show you how to design them in Advanced Design. So I will now move on to Advanced Design. So first thing we'll do is look at the configuration to see what standard is being used. So for timber, we have the OAD 6 2019, so that's the Canadian code. We also have the NDS 2018 for United States. I will start with the Canadian code and later I will switch to show you the difference. So I will only create a very simple model with a single beam. So I will use a linear element. I will snap it on the grid with a length of 5 meters. Then I will change the material to use the correct type for glued-laminated. So I already have two materials here in my list, but if the material I'm looking for is not on the list, I can access the library of material with the icon next to the drop-down menu. So there is a new category for timber Canada and another category for timber US. So I will be using here a material from Canada. So it's the this one right here. I will change the cross section for a glued-laminated section. So here I have two of them. I will select the GL 175 by 513. We can also have a look at the library. So using the first of the three icons. So for glued-laminated, there's one category for both Canada and US. So then I will add supports to my model. So I will use rigid point support at both extremities. I will release the rotation around the y-axis to get a pinned connection. So I'm leaving the other degrees of freedom fixed just to make sure the model is stable. Then I will need to include some loading. So I could right click on loading, create several case families, and I will include one live load and one dead load. So the first dead load automatically includes the dead weight of all the elements included in the model. I will include an additional dead load by using right click and load selection. This is the easiest method in my opinion because it will automatically create a load that covers the entire length of the element. So I will include -1. Then for live load, I will include something a little bit bigger. And I will use a second method, which is to select the linear load and then trace it manually on the screen. We'll use -5. So when they are too small to see like this, I could right click and load autoscale to make them visible. Then I will also need load combinations. I can double click in the palette on combinations to open the dialog box. The easiest method is to use the generator, and you can see the flag to represent what code is currently being used. If you are manually creating your own combinations, you have to make sure they're included in the Timber tab. It's the same thing for the other materials also. So you have different categories. So in deflection, those are all the combination used for deflection, but also their duration. And for profile, those are the ones used to check the resistance of the element. So that's why they have type ultimate limit state, and they also have a duration. Okay. Now, if I go back to the properties of the element, first thing I will do is fold everything because I don't need to touch any other of the finite element properties. And we will want to focus on the design options. So the first checkbox to calculate, this is to turn on and off the design for specific elements. It can be useful if you want to save on calculation time when there's a lot of elements that don't need to be calculated. Then in general design information, so those will affect the resistance of the element. So for example, we can change if the conditions are wet or dry, if it's treated, untreated. Also, if there are holes in the element, so we can reduce uh, the area of the section. So this will affect, for example, the tension and the shear resistance. I will leave it at 0 for now. Temperature, I think this one is only for the US code. I don't think it will make a difference for Canadian code, if I recall correctly. So deflection, by default, it's turned on. And so if you recall in the combination, in the load combination dialog box, so there was 2 limits for deflection. So all of the load combinations for now are using the second limit. So it will be L on 300. Then we can also specify a fixed maximum value. For buckling, so this one we're forced to leave it on. And for our model right now, it's not going to make any difference because we don't have any tension or compression in the element. But I will still show you the dialog box and the options. So it's very important to make sure you have selected correctly if it's braced or unbraced. It can have a big impact on the K value. The LFZ and LFY you see here, they will be calculated during the analysis. So this will tell you exactly what length were being used. And with the first option, we have access to the dialog box to configure how the length would be calculated. So the L0, this is for the reference length. So this is the L portion of the KL value. And then LFZ, this is the both K and L multiplied together. So by default, everything is automatically calculated. It will use the same method as the steel design. If we wanted, we could force a different value. So either impose value, or it could be based on a ratio of the element length, mesh size, or a ratio of the superelement, if we defined it as a superelement. I will leave everything at automatic. Then lateral torsional buckling. So this is where we can define if it's fully braced, only braced at bearing point, or we could define our own length if we had intermediate supports. If it's fully braced, we can also just leave it off like this. Then bearing. So we can have values for both extremities and for internal bearing length. So I'll use two different values, 0.2 on one side and 0.1 on the other side. We can also define notches at both extremities, either on top or bottom side of the beam. And finally, we have options for curved glue lines. So when everything is defined, we can launch the analysis. So we'll click on the Analysis tab, create a new analysis model. I will check Fine Tillman calculation and timber design, of course. So at the top of the screen, we have the timber design result group. So right now we're using a resistance work ratio and its actual moment. Could also select bearing and shear. So we could see also some intermediate values. So for example, the some of the K coefficients. And we have some values for deflection, buckling, and lateral torsional buckling. So those are similar to what you have for steel design. So we could check what is the LU. In this case, there's no value because the lateral torsional buckling was turned off. We could look at the slenderness ratio, the LFY, LFZ. If we want more detail on where the 11.9% comes from, I could select the element and click on Shapesheet. So this will bring a dialog box with a lot more information. So if we start with the first tab, we have all the properties of the section with all of the K value that were assigned to it. We also have all the properties of the material. So in deflection, we have our results for deflection. So we're at L1000. It's only work ratio of 14%, and the length that was used is 5 meters. Then in strength, we can see exactly what equation were used. And we can click on Edit Detailed Report to have the full page report. So the information is similar to what we had in the log box, but it's all condensed in one page, and that's easier to print. If we made changes to the member, it's possible to recalculate only the wood design portion. So for example, I will change the bearing length and bearing width. So we can click here on the bottom portion of the launch calculation button and launch only timber design. When we have a selection on the model, we will also get this dialog box to ask us if we want to calculate only the selection or the full model. So now we get the same value on both sides. Now let's have a look at the American code, so the NDS 2018. And so if I close the model and open back the configuration menu, so I change the localization to United States, it will switch all the settings automatically with the NDS code. Also, we have the create load combination, and we can select ASD or LRFD here right next to combinations. So I now reopened the same model I had before. So one thing we could do to improve it is add some columns. And so I'll do a similar procedure of changing the materials. And so I will change it actually for all three of them. So I will select a material from the US library. So what I was using previously was from the Canada library. So I'll change it and select one of them. So this list comes directly from the supplement of the NDS 2018. When we've included it, we can now select it from the drop-down menu. I will also change the cross-section. I'll use the same for both. And for the design option, so it's the same list of options as we've had before. Um, but of course, the coefficient associated with those parameters are not the same exactly. In this case, we could also include temperature. So if we look at the load combinations, uh, so I will delete everything and regenerate them from the US code. If we look at timber, we can see that they're included in the calculation of the profile resistance. I will launch the calculation again. And so similar as before. So if we look at the shape sheet, so we have all the information of the section and all the coefficient that will affect the resistance. So instead of using letter K, use the letter C, but it's a similar principle as the Canadian code. And also we have the properties of the material. We can also display the shapesheet of one element using the shortcut Edit Detailed Report. And also, I forgot to mention it. So if we look at the tab on strength, we can see for each verification what is the critical load combination and the equation with the values that were used. Now, if you wanted to generate um, uh, that the report for multiple elements, what I could do is select them in the model and use the report generator directly. So now if I generate the shape sheet, it will generate it for all of the elements selected on the model. And so we have all three elements, so linear element number 1, linear element 2, and linear element 3. If you want to identify them on the screen, you could add this information as annotation. So in the display settings, so we have the list of all the different elements, and so I could go to linear element, click on the plus next to annotation, and include any information I need. So the cross section could be useful for design. So now I can say exactly what's assigned, what is assigned everywhere. There's also an extra table of result that's available in the generator. So if we go to table, temporal analysis, so we have already seen the shape sheet and the result category, but we also have load case. If we want to know the quantities, we could also include the bill of quantities. So we can see a summary of the duration factor for each load combination. So they were grouped together here, 102, 103 with the same duration, and then 101 with a different value. And then the bill of quantity per material, per cross section, and then per cross section per length, because not every member with a 175 by 513 has the same length. So we have 3 meter columns and a 5 meter beam. And so thank you for watching. I will now conclude the presentation. If you have any question, you can ask them on the Vima platform. You can also contact me directly by email at the address listed in the PowerPoint presentation.